That is Newton's laws. That is what we were discussing in the previous class, and today we have to discuss the third law of Newton. Third law of Newton. Okay. So before we come for that, let me remind you the first two laws. The first law we learned, it was until an object, okay, until a force is acting on an object, an unbalanced force is applied on an object. An object at rest remains stationary. There is no motion. Meanwhile, if it is already in motion, it won't be either increasing or decreasing the velocities. It moves at the same velocity, constant velocity. Okay, so this is the first law. Second law says that the acceleration acting on an object. What is the acceleration of the object? It is directly proportional to the force and it is inversely proportional to its mass. Directly proportional to the force, inversely proportional to the mass. Okay, so this is the second law. And the third law says that every action, whatever the action we do have, for every action, there is a reaction. And this reaction gonna be equal in magnitude. The force is equal and opposite in direction. The direction will be right opposite. Okay, right opposite. You hit on the wall, that is the action. You are getting a pain back because of the reaction given by the wall over your hand. And that's equal in magnitude and opposite in direction. Opposite in direction. Okay, so imagine now a gas balloon. You are filling up the gas balloon. Okay, the balloon you are filling up with gas and hydrogen gas or helium gas or whatever. So once you fill up this balloon with gas, once the gas starts leaving out, the balloon moves. Balloon moves forward. Actually, we think it like action. It is not the action. That is the reaction. So what is the action here? Action is the gas is leaving out. So when the gas is leaving out, that's the first process, first step there. That is the action. As a result, the balloon is moving forward. Okay, if it is connected over a rod to slide, when the gas is moving backward, when the air is leaving backward, that is the action. As a reaction, equal in magnitude, opposite in direction, the gas cylinder moves or slides along the bar, along the rod forward. Okay, so these are action to reaction. And when we swim, when we paddle, or when we what do you call rowing a boat, okay. So in all these cases, we are giving an action, okay, and we are getting a reaction. We are getting a reaction. Maybe because of that reaction, our works are being done. Okay, rowing a boat, I'm rowing the boat backward. The boat is moving forward. Okay, and the opposite happens when I want to move backward. Okay, when we are swimming, also the same. We are moving our hands to swim. So the action we are giving using our hands and the legs, we are moving forward. So that is the reaction. So for every action, there is an what you call equal magnitude, opposite direction. So this is the third law. It's very simple. Only by the applications, the examples you have to learn. So let's write there. Every action has an equal and opposite reaction. Has an equal and opposite reaction. Every action has an equal and opposite reaction. So you can just draw those two pebbles given, two circles given, showing you that equal lengths by the arrowheads. Can you see both the arrowheads are equal? The length of the arrows equal and opposite in direction. Arrowhead shows you the direction and the length shows you it's having an equal length. It indicates that forces are equal. That is what it is given as capital F for both sides. Okay, mark it down. Okay, and let's write there are some examples where the third law is applied on. Okay, examples swimming, swimming, rowing a boat, rowing a boat, moving of a gas balloon. A few examples. Right. And so far now we are done with the first topic that we have taken this month. Okay, actually that's about the Newton's laws of motion. That's all about. Okay, we learned about all three laws, and basically the second law related formula we derived as F equals ma, and we learned how to apply them into questions. Okay, and the second topic for this month that we are taking is the momentum along with mass and weight. Along with mass and weight. Right? Fine. So momentum. So what is this momentum? Momentum. So what is mean by momentum? Simply to say, an object in motion. Already an object is in motion, let's say. And how difficult to stop the motion. How harder it is to stop the motion of the moving object. That is what we term as momentum. But in physics, we take this momentum as the product of two things. Okay. Let's say this is the object. The object is having a mass m and it's moving at a velocity of v. I'll show this direction. So the momentum is obtained as the product of mass and velocity. So the direction of the momentum will be also the direction of velocity, which we term as capital P here. I mean P here. P is the symbol that we are giving for momentum. Momentum. So how do we get the momentum? Momentum is equal to the product of these two, mass into velocity. Momentum is equal to mass into velocity. Mass is m into v, it's v. Alright. And remember, momentum, when you take this momentum, mass is measured, it should be measured in kilograms. Okay. Mass should be measured in kilograms, whereas the velocity should be measured in meters per second. Okay. So momentum is given as kilograms meters per second. Per second. In case if any other units are given, we have to keep them converted. So if it is given in grams, you have to convert them into kilograms. If it is given in grams, you have to convert it into kilograms, and then you have to get the answers found. Okay. So let's try there. Put that up with momentum, and we'll write a small definition over. Momentum is momentum is momentum is. So can we write it as ms minus 1? Yes, we can. Okay, that ms minus 1 is what we are using as meters per second with a slash. Okay. Momentum the product of is the product of mass and velocity. Mass and velocity. And then note the down. Note it down. What is given on the board? Are you done?
Yes, sir.
Okay. So you can see the object is given same like. Okay. Now, using this formula, we are building up some relationships as usual. So every formula, you should be able to build up the relationship between the factors. So here it is related to momentum. So I see, we obtain the formula momentum is equal to mass into velocity rate. So accordingly, let's say if I'm going to take velocity is constant. If v is constant, when v becomes constant, you are not changing. Okay, you are not changing the v. Then mass and momentum becomes directly proportional. So momentum will be directly proportional to mass. What do you mean by that? You increase the mass, momentum increases. You decrease the mass, momentum decreases. Momentum decreases. So it's something like this. Two objects we consider. I'll give you the example. Okay. Two objects we consider. This is M1. Okay, and this is M2. Right. And I'm showing you like bit larger. M2 is bit larger. And also I'm writing M1 and M2 you consider M2 is more. And also just because of it is shown as M2, okay, M2 bit larger, right? It is not always more in the mass because just imagine you are going to take a metal ball, a smaller metal ball you are taking, okay, a smaller metal ball and a larger rubber ball, larger in size, but the density of rubber is less, right? So at that time, it may be having a smaller mass. So it is not always by the size we can assume the mass should be more or less. Okay, but here we take it as M1 is less, M2 is more. Here we are giving it as an example. Okay, right. So M2 is more here. Okay, and both of them are moving at the same velocity to the same direction. So I'll mark it as VV. So since both of them are having the same velocity, when you're gonna count for P1 and P2, definitely P2 will be more. P2 will be more as the mass of M2 is more than M1, more than M1, because this is directly proportional. So the same way when you take, if let's say now the mass is a constant, mass is constant. If mass is constant, momentum is directly proportional to velocity because both these factors are also in the same state either side of the equal mark. So you increase the velocity, momentum increases. You decrease the velocity, momentum decreases. So let me take now the same mass, two objects having the same mass, right? I'll mark it as mm to show you that both the masses are equal. And I'm giving a velocity v1 and giving a velocity v2 here. So as m and m both the same here, and v1 and v2 when you compare, v2 is more. So direct proportion, momentum should be more in the second case. Momentum should be more in the second case. Understand? So this is how we have to compare. We have to compare. Okay. So some questions asked you in MCQ, a short question. They will ask you to the same velocity given in two objects. If you want to increase the momentum, but I was supposed to do to increase the momentum, you have to increase the mass. Okay, you can't increase the velocity because velocity has to be kept the same. So likewise, you should be able to compare. Okay, let's take the note quickly. If you are done, give me a thumbs up.
Okay, sir.
Give me a thumbs up. What's that? Okay. So momentum is equal to mass into velocity here. So F equals ma using momentum. F equals ma using momentum. So we are going to build up the relationship between this force and momentum. Force and momentum. So how to build it up? How do we take that? Now we learn P is equal to M into V, right? P is equal to M into V. Okay. And we know F is equal to M into A. Force is equal to mass into acceleration also V. Force is equal to mass into acceleration. Okay. So you see, let me start from F equals M into A. I'm starting up with F is equal to M into A. So for an object, when you are applying a force, so let's say this is the object. Okay. The object is having a mass M and you are going to apply a force F. Okay. And we know when you are giving an unbalanced force, there will be an acceleration, either an acceleration or a deceleration depending on the direction and the force. Now, without giving A, what I do, I'm giving you, initially it was at velocity U. It was at the velocity U. So from velocity U, it is increasing up to V. It may be either increasing or decreasing. Okay, it may be either increasing or decreasing. So velocity, what happens from U, from the starting velocity, it is getting the second velocity V. Okay, U to V, and the time taken is T. Time taken is T. So this is the data given. So using this, I'm going to build up a formula here. That is, I'm going to build up the relationship. So now you see the mass is same, right? But acceleration we know. You can find the acceleration using this velocity change over time. How do we take that? Velocity change over time. V minus u over t. So instead of a, I can write v minus u over t. V minus u over t. So now when I multiply this, m into v comes mv minus m into u, mv. Dividing by, again do we take mt? No. M is up, down, it's nothing. So it's only t. So you see force is equal to mv minus mu over t. mv minus mu over t. Now, already we learned momentum as P is equal to m into v, right? M into v. So mass into velocity is the momentum. And here you can see two velocities are taken, final velocity and initial velocity. So what is the meaning of that? If you consider two velocities, one as final and the one as initial, final velocity must be giving rise for final momentum. Initial velocity should be giving for initial momentum. That's the case. So accordingly what I do now, mv, I take it as final momentum. I'll take it as final momentum final. Minus mu, I take it as momentum initial. Momentum initial. That means P2 minus P1 like P2 minus P1. And now I am dividing by the time taken and this becomes the force. This becomes the force. So you can see here now force is equal to momentum difference between dividing by the time taken. So further I can write F is equal to delta P over delta t, time taken, time taken. So you can see we started from F equals m into A and we are ending up with a formula force is equal to momentum change over time taken. Momentum change over time taken. So this is how force and momentum they are getting connected. So remember, whenever there is a question given with force and momentum connected, this is the formula we have to use. This is the formula we have to use. So accordingly, force equals change of momentum dividing by the time taken. Dividing by the time taken. Okay. And also, you see, when you come for force, force is given as m into A, where the mass is measured in kilograms, acceleration is measured in meters per square second. So the force was given in kilograms, meters per square second. Per square second. That is the fundamental unit. That is the fundamental unit. Kilograms, meters per square second. That is the fundamental unit. And when you come for momentum, momentum is equal to m into v. Same m, but acceleration only now it is velocity. So this is measured in kilograms and this is measured in meters per second, right? Earlier per square second or per second. So because of that, momentum's unit becomes kilograms, meters per second. So these are 2 points where basically we, confuse in questions. So probably you might confuse this part in the questions and sometimes they will ask you what is the fundamental unit of force. So in fact, the force is measured by Newton. Newton is the SI unit, standard international unit. But the fundamental unit of force is kilograms, meters per square second. Kilograms, meters per square second or second square. Clear? Clear about that? Okay. So let's write this down. Okay. We'll put the topic as F equals ma using momentum of an object. F equals ma using the momentum of an object. And then we'll write this down. Take this as a keynote. So I couldn't understand what the triangle means in the red box. Yes. Now, final minus initial we took, right? From the final momentum, sorry, we are reducing the initial momentum. So we are getting a difference, right? So this difference is not indicated by delta. This is delta. The triangle we name it as the delta. Delta refers to difference. Difference between. Okay. Got it? Done. So let's put the topic now. Let's write some questions now. Right there. Now, usually this is very common question. Okay, about momentum when you come. There's a very common part in the paper. Okay, when you come for this motion and all, very common you can see in all. Most of the papers. Okay, so they will start up with what is the formula linking momentum, mass, and velocity. That's a question carrying 1 mark. It's very easy. Okay, we'll also start the same right there. State the formula. State the formula. State the formula. Linking. State the formula linking momentum. Momentum. State the formula linking momentum, mass and velocity. Mass and velocity. And write the formula. P is equal to m into v. You can write momentum equals mass into velocity. P is equal to m into v. Okay. Now let's write a question there down. An object of mass 1500 grams. An object of mass 1500 grams moves at a velocity of 20 meters per second. 20 meters per second. Calculate its momentum. Calculate its momentum. Calculate its momentum. Get me the answer.
kg ms minus 1.
Can you text? What's the answer you got? What's the answer?
30 kg ms minus 1.
Okay. How come? P is equal to m into v. Mass is 1500. Can I apply 1500 grams? I have divided by 1000 to make it kilograms. I can't write grams. Okay. And then I have to multiply it by what is the velocity given, what is the speed given there? 20 meters per second. 20 meters per second. Right? So it's almost 1.5 into 20. 1.5, 15 into 2, 30. Unit is must. Kilograms, meters per second. 30 kilograms, meters per second. That's the answer here. 30 kilograms, meters per second. Okay. Right. Let's put the topic now. Just a simple example for the calculation. Right there. Conservation of momentum. This is what the most important in part 2 paper. Okay. Conservation. Sometimes in part 1 also it comes. Conservation of momentum. Okay. Conservation of momentum. So what's this conservation of momentum refers to? Okay. Conservation of momentum. Conservation of momentum. What is the meaning of this? Now let's say I'm going to take an object here, right? And this object, I'll mark it as M1. Okay. And it's having a velocity V1. It's having a velocity V1. Another object is there. Another object is there. M2. Also having the velocity V2. V2. So these are the two objects. These are the two objects. Initially, at the beginning, both of them are having two velocities. Okay, two velocities. Let's say they are moving on. They are moving on like this. Somewhat one is speeder than the other, or whatever. They hit. They collide. At a time, they collide on. Until they collide, both of them were having the velocities separately, so the momentums were separately. Now, once they collide, as a collection, as a combination, as a group, they continue their journey. Either they stop or they move in the same direction, increasing the speed, decreasing the speed, or they divide into two parts or whatever that may happen. Okay. So that happens after the collision. Now, after the collision, I'm going to take it as the combination of two things. One is M1, the other one is M2. Okay. So the mass, if it is combined together, totally when we are taking, there cannot be changes in mass, right? Unless the parts are broken, if the question says. So there is no changes in the mass. Mass will be the same. So the total mass is there. So these two are separately moving and now they are combining means total of the mass is there. But the velocity cannot be V1 plus V2. So a different velocity I am taking as V. Different velocity I am taking as V. So I'm going to tag them in this way. Okay, I'm going to tag them in this way. That is, this is before the collision. Before the collision. Before they collide on one another. And this goes as after the collision. Before the collision and after the collision. Before the collision, after the collision, two things were taken. Okay. Before the collision, what is the momentum? After the collision happens, it remains the same. Okay. So what is the total momentum before the collision? Will be equal to the total momentum after the collision, and this is what the conservation of momentum says. Okay. So the law of conservation of momentum says that, right? The momentum before the collision, the total momentum before the collision is equal to the total momentum after the collision in the same system. Why? No any other particles have been added. Nothing gone out, nothing came in, the same stars. Okay. Maybe earlier they were at rest, one was rest, this is rest, this is moving. And then collectively together they move. Or else both of them are moving, one is faster than the other, so it hits on. That is how the accidents happen, right? Okay, most of the time hits on and together they move. Sometimes both together they are moving in the opposite direction like this and they hit. Okay, depending on the speed in which direction it is, either to right or left, it may be drag. Sometimes what happens, as one group they are moving, suddenly because of an explosion, bursting, okay, or a blasting, they split. They split and move away. So anyways it may happen. Whatever, before the collision, before the change, what was the total momentum? After the change, what was the total momentum? Should be equal. Should be equal. So this is what the conservation of momentum says. Momentum says. Okay. So for the topic conservation of momentum, and let's write that down. Let's write down. It states that it states that it states that the conservation, the total momentum. It states that the total momentum, the total momentum of a system, before the collision, before the collision is equal to the is equal to the is equal to the total momentum, total momentum after the collision, total momentum after the collision, after the collision. Full stop. That is momentum is conserved. Momentum is conserved. Momentum is conserved. Okay. Now have a look. Momentum before the collision equals momentum after the collision. That is a theory. Now let me find out the momentum before the collision. Now momentum before the collision, there are two people, M1, M2, two different masses are there. M1 is having V1, M2 is having V2. Remember, as far as the velocities are in the same direction, you have to take them as plus. If they are in the opposite direction, you have to take them as minus. Okay, so accordingly, both of them are having in the same direction moving on, so it should be plus. So I'll take it. How do we find out the momentum? M into V. M into V. So the total I have to take. Before is this. This is before. Before what happens? M1 into V1. Okay. M1 into V1 plus total, right? M2 into V2. These are the only two people, so collectively we take. So this is the total before the collision. And what is the total after the collision? M1 and M2 together, right? So I can take it as M1 plus M2. And moreover, together they do have one velocity. M1 plus M2 into V. Into V. So this is how we are building up the formula, the relationship. It's a sort of relationship. Okay. So using this theory, we are finding out that we are calculating one of the factor which is given under this conservation of momentum. So they sometimes give all these things and they ask you to find out the final velocity. For any of these factors, giving the rest of the parts, any of the factors they might ask you to find. Okay, but this is the general theory. So I'm giving you in short. Very simply, I'm extracting out the theoretical area. Okay, and very simply in a short note, I'm giving you the theory. So it's very easy for you to learn. Okay, so get the proper picture of the lesson and get it done. Okay, if you learn that way, definitely you can score the marks in your paper. But you have to practice the questions. Okay, so let's note this down. And meanwhile, when you write, make sure you understand the points. Okay, read, understand the points, and then write. And if you ask me, so can we use the same formula for every question? No, not like that. Theory is same before collision, after collision. Okay, but before the collision, it might not be the same M1 and M2. It may be any other. Okay, and this might not be connecting. Maybe splitting over. Maybe moving in two different directions. So in that case, this won't be same. This may differ. The second step is there. This may differ depending on the question, but the theory is same. Before collision momentum equals after collision moment. Okay, so let's write it down from here. Draw the diagram and just below them mark it down. And meanwhile, if you got a question, Shareen, you can drop a message. Sharin done, right? Okay. So this is what happened.
Sorry, sir. I had another class which finished at 8:30.
Oh, is it?
They normally told at 6:30, but today it finished at
Okay,
8:30.
okay. I've done a big part now actually about the momentum. Fine. So this is theory related to. So you can go ahead with that. I'll explain it again when we are coming to the questions. Now we have to do the questions actually now. So this is related to conservation of momentum. Momentum, what we spoke about here. Momentum is equal to, it is obtained by mass and velocity. Mass and velocity. So what is the mass multiplied by its velocity? That is momentum. So here we speak about the conservation of momentum. This speaks on the relationship between the momentums before and after a collision. A collision means hitting on one another. Okay, so hitting on one another, maybe like combined together or maybe splitting over. Anyhow, two different instances are there, initially and after. So in that case, before the collision, what is the total momentum will be equal to the total momentum after the collision. Before the collision, the total momentum is equal to the total momentum after the collision. After the collision. So let's take some examples. Okay, the same thing as a general example, I'll take first initially. Okay, I'm going to write some data actually. I'll say this M1. I'll mark it as it has about 2 kilograms, and this is 2.5 kilograms. 2.5 kilograms. And this was moving at 10 meters per second and 15 meters per second. Okay, 15 meters per second, and that is how it can collide. It can collide. Why? The person who is coming behind should be having a high speed to hit on the first person, right? If he is having a lower speed, he can't hit on the first person, right? It's not possible. Or else he should be having a higher mass. He should be having a higher mass. Why? Momentum is high, then can you remember earlier we said? So if the momentum is, if the speed is high, momentum is high. Or else if the mass is high, momentum is high. So here the mass is also less than. So this should be having a high. So accordingly, anyhow, is around 15. All right. So these two combine, and then what happens? Okay. Then what happens? This is M1 and this is M2. After the collision, they together move. They together move. After the collision, both of them together they move. So we want to find out the velocity here. We want to find out the velocity here. How do we find out? Momentum's conservation law says that before the collision, momentum is equal to after collision momentum. So how do we find it? Now look at this. I hope Sharin you understood clearly. So this is have a look. Okay. Before the collision. Now how many people are there? Two people are there. Two people are there. Okay. So both these two people I have to find out separately. How to find out the momentum? Momentum P is equal to mass into velocity. That is a formula. Momentum is equal to mass into velocity. So I have two people here. First person has 2 kilograms and 15 meters per second speed. Second person has got 2.5 kilograms and 10 meters per second speed. So I have to find out the total momentum, right? Momentum before the collision, the total momentum. Total momentum. Okay. So how do I take now? Mass into velocity. So this person's momentum I'm taking. Okay. What is this momentum? M1 into V1. That means 2 kilograms into 15. Okay.
I mean,
Let me take it as V1 and this is V2. So I have to take it as M1 into V1. M1 into V1 plus, because I have to add. That is because of both of them are in the same direction, so I have to add. If they are in the opposite direction, I have to reduce them. I have to subtract. So now M2 into V2. Why? Momentum of the first object plus momentum of the second object. M into V is equal to. Now both of them combine. According to my question, this is the example. I say both of them are combined. Combining together. So M1 plus M2. Okay. Into M2. Sorry. plus m2, m1 plus m2 should be moving at one common velocity v. And the question asking you, what is this v? You want to find out v. So how do we do that now? I need to find out v, right? I need to find out v. Okay. So let me substitute this first. How much is m1? 2 kilograms. And in fact, in this question, I have given all of them in standard units. So you don't want to worry. In case if it is given in other units like grams and all, you have to convert them. Okay. As per the example we did earlier. 2 kilograms. 2 kilograms into what is the velocity here? 15. Okay. So let me write without the units there. 2 into 15 plus. Final answer is must to make the unit. Okay. In between the steps, it is not must, but the final answers, we have to mention the units. 2 into 15, 2 into 15 plus. Next one is 2.5 into,
2.10.
and moreover, guys, when you substitute them, properly substitute in order. M1 means M, you have to take M. You can't write V1 first. So here you are writing M1, V1. When you are substituting, you are writing V1, M1. That's all. In the question paper, in your marking scheme, it mentions you have to substitute in order, otherwise, don't give marks. Clear? In the exam paper, that is how it comes. So properly substitute in order. I didn't mean that write in the same line down. That is not the idea. When you write them, if you took M1, when you substitute, take M1 first. If you took V1, take V1 first. But the usual order is M1, V1. Okay? Is equal to. Now, what is the total mass? We assume that nothing added, nothing gone off. The same substances are there. So M1 plus M2. M1 is 2 kilograms plus M2 is 2.5 kilograms into V. Now what is the total? 2 into 15, 30. 2 into 15, 30. 2.5 into 10, 25. Okay, 25. So 30 plus 25 is equal to 2 plus 2.5, 4.5 into V. Okay, so 30 plus 25, 55 is equal to V. I am taking 4.5 here. 4.5 V. So get me the answer now. Clear? 30 plus 25, 2 into 15, 30, 2.5 into 10, 25, together 55. That 4.5 I have taken here, dividing by 4.5. How much is the answer now? 55 over 4.5. Give me the decimal value, right? 12.
12.22. Fraction answer 110 over 9.
Yeah. So you can keep it like it's recurring now. 12.22 meters per second. So what is the final velocity of both of them? 12.22. So can you see it is not 10, it is not 15, somewhere between. Collectively. This is because of to maintain the same momentum. Did you understand that point? Shall I write this down? Take it as an example question. So we didn't write the question, but here it's clear. The data are given. It's asking you what is V. You are done? Give me a thumbs up. This is, yeah, sure. This is, have you done? Okay, good, right. So, fine. I hope the theory is clear. Let me take the next part now. Mass and weight. I'll give you some questions related to this, okay? Let's come to the next part. Mass and weight. To the topic. So, do you know the difference between these two words? The mass and weight. What is the difference? Any idea? What is mass? What is weight? Anything? Now, in our day-to-day life, we measure different things, right? Okay. So basically, when you are going to the shop, you're asking, no, give me 1 kilogram of sugar, 2 kilograms of rice. No, you're taking. So, how do you refer this? What is it? Is it mass or weight? What is that?
Hmm?
Is it mass or weight? Weight. Basically, we term it as the weight, isn't it? Okay, bara ki we are asking, na? Bara kochara. So, bara, the word bara we are referring as the weight here. Skande, that is mass. Okay, skande and bara, mass and weight. So in our day-to-day life, some of the terms we are using, guys, it's totally opposite for science. Okay, but what to do? We are using, because when you're gonna apply this, when you in front of the shop retailer, he'll be looking up and down. He doesn't know about that. Okay, when you learn that, you can see. So some words are wrong. So correctly learn them. What is this mass? When you come for an object, okay, object. So in this object, how much matter it contains? Amount of matter. Amount of matter it contains. This is called a mass, simple M. This is what we term as the mass. Okay. So the mass is measured by kilograms. Unit kilograms. What is the unit? Kilograms. So symbolized by simple M, measured by kilograms. Kilograms. Grams also we are using, but for small objects, some questions carry out with the same grams. But the SI unit is kilograms. This is the SI unit. SI unit. Okay. Then what is weight? What is weight? Weight is the force acting on this mass due to the gravity. Due to the gravity. Now, there's an object. This object does have an amount of matter. So, how much matter this contains is called its mass. And the gravity is down, right? Towards the earth, right? So, due to the gravity, when I leave this, it goes down. When I leave this, it goes down. Why? Because there is a force acting on it towards the gravity. This force, due to gravity, the gravitational force, is what we term as weight. Is what we term as weight. So, what is weight here? Weight is the gravitational force. So, you see, gravity is down. Due to the gravity on this object of mass m, there is a force acting down. And this force is what we term as weight. Weight. So, we are using the formula F equals m into A to obtain this. You see the mass is same. Acceleration is the gravitational acceleration. Acceleration is the gravitational acceleration. So acceleration is towards the earth due to gravity. So when you multiply these, you are obtaining the force, right? Force due to gravity. Force due to gravity, we term it as gravitational force, which we term as the weight W. Weight W. So this is how we obtain the formula W equals m into G. W equals M into G formula is obtained from this. Mass here is measured by kilograms. Gravity is measured in newtons per kilogram. Okay, newtons per kilogram. So accordingly, weight is measured also in Newton. So this is measured in kilograms. And this is acceleration. Usually are measuring in meters per square seconds, right? This is also meters per square seconds only. But as a unit, we are using newtons per kilogram because gravitational field strength is what we are using here. Gravitational field strength is what we are using here. So the gravitational field strength is given in newtons for 1 kilogram. Newtons per kilogram. So that newtons per kilogram, when we use kilogram to kilogram cuts, so the weight is given in Newton. Since it is also a force given in Newton. So we already know that how to define Newton. 1 Newton refers to on an object of 1 kilogram to give an acceleration of 1 meters per square second. For an object of 1 kilogram to give an acceleration of 1 meters per square second, what is the force you have to apply? That is called 1 Newton. That is called 1 Newton. So the same way, okay, when you come for the gravity is 9.8 newtons per kilogram. That is a real value, 9.8, or it comes sometimes some decimals. But for easy calculations, we use it as 10. We use it as 10. But remember, when you come for your question paper, maybe the term papers for the final exams, okay, remember to read the instructions given. Because in the instructions, there is a point, probably the last point, okay, it will be mentioning use G as 9.8 or use G as 10. What is given there in the very first page, that is what throughout the paper you have to use. If the first instruction, okay, in the first page, the instruction says to use G as 9.8 and you are using 10, totally wherever you use that, you are losing your marks. And it mentions 10 and you are using 9.8, still the same. So you have to definitely read that part, how it is given. Most of the time they will be giving it as 10, sometimes 9.8 may be taken also. So anyhow, let's say 10, if G is 10 and 1 kilogram mass that you are taking, weight will be 10 Newton. So let's say an object of 1 kilogram and the gravity down is 10 newtons per kilogram. The mass is 1. So what will be the weight? Weight is equal to m into g. 1 kilogram into 1 Newton per kilogram, 10 Newton per kilogram. Okay, 10 Newton per kilogram. 1 into 10 gives you 10 Newton. So by this example only, we build up for easy calculations as 1 kilogram is equal to 10 Newton. 1 kilogram is equal to 10 Newton. How do we take? Because of this phenomenon. Okay, because of taking 10. Now you see, since we took G as 10, 1 into 10, 10 Newton. Okay, now I told you, right, if it is your 9.8, your answer may go wrong. Why? If it was 9.8, 1 into 9.8 will be resulting 9.8 Newton only. 10 Newton won't be there. So that is the difference. That is the difference. So anyhow, for easy calculations, if you take it as 10, 1 into 10, 10 Newton, that means 1 kilogram is equal to 10 Newton. 1 kilogram is equal to 10 Newton. But remember, if G is 10. If G is 10. If G is 9.8, that go 9.8 Newton at last. Hope it's clear. So let's write down. Put the topic mass first. I mean, we'll write, I think we already put the topic, no, mass and weight. Right, we'll write there as points. Mass is the amount of, mass is the amount of matter containing in an object. Mass is the amount of matter containing in an object. Mass is the amount of matter containing in an object. Containing in an object. Okay. Right in the next line. The force acting on an object. The force acting on an object towards the earth due to its gravity. What is the Earth due to its gravity? It's called the weight. It's called the weight. It's called the weight. Okay. So let's write this down. What is given over there? Finish it up, please. Done?
So I have a question.
Okay.
So that means now when we're finding the weight, that means for this last answer or like 10 kilograms times 10 newtons per kilogram, that means like they are cancelling the units which are equal to both numbers.
Cancelling what?
Cancelling of the units. Like
Yes,
in
kilograms to kilograms should be cancelled so that Newton comes.
okay, sir.
Because this is per kilogram, right? Per kilogram means when you take it up there, it becomes kg minus 1. So kg plus 1 minus 1 cancels out.
Sir, will you be sending the recordings to the app you send us?
Oh yeah, I'll forward. And you can get it in that, what do you call, the online classroom. There will upload. Okay.
Okay, sir.
Okay. Let's take a small question there. Have a look. Look at this question. Can you give a try? Give a try. A boy of mass 43.2 kilograms runs and jumps onto a stationary skateboard. So two objects. One is the boy, the other one is the skateboard. Okay. So the boy is running, but the skateboard was at rest. At rest. So first, we'll take like this. Okay. On your book, take it as questions. Mark it as question. Okay. And write down the question quickly. Write down. Write it down, and no need to draw the entire boy's image. You can just take it as in Edexcel system, okay, like a skeletal system. Just take it, okay, as a symbol that you are drawing, and draw it along with a small rod, horizontal plane, and then take the first question down. Hurry up. Okay. So give me the answer now. Get me the answer. How to find out the answer here? You see, first thing, state the relationship between momentum, mass, and velocity. So you can write now momentum is equal to mass into velocity. You can write. Okay. Second question. Second question. It says there was a boy. His mass is 43.2 kg, and was moving. He was moving. Okay. 43.2 kilograms mass was there for the boy, and he was moving at a certain velocity. And the boy lands on the skateboard with a horizontal velocity of 4.10. And the skateboard, okay, it was at rest. Starting velocity was 0. Velocity was 0. Let me take it as V1. And this is 0. 0 velocity, right? The skateboard has a mass of 2.5 kg. So what is the mass? 2.5 kg. So you see, using ideas about conservation of momentum, calculate the combined velocity of the boy and skateboard just after the boy lands on it. That means after the collision, once the boy lands on, okay, you have to find out what is the final velocity. Final velocity. How do you take? You have to write a small statement. What is it? Total momentum before the collision is equal to the total momentum after the collision. We have to write this. Okay. And what is before the collision? You can see the person is 43.2 kilograms and 4.10 mass. Okay, mass per second. Sorry, meters per second. So I'll take it straightly. I don't want to write M1, V1 and all. Straight away, let me write 43.2 into 4.10. 43.2 into 4.10 plus. Next one is 2.5 kilograms, right? But it is at rest. So since it is at rest, 0. So straight away even I can write it as 0. But still I am showing you 2.50 into 0 is 0. Again, so you remember an object at rest, even if it's having 1000 kilograms, momentum will be 0 because momentum since the velocity is 0, it's at rest, momentum should be 0. Okay. So equals to total momentum after the collision, boy lands on the object. So landing on the object means 43.2 kilograms of person lands on 2.5 kilograms skateboard. So I have to take it as 43.2 kilogram plus 2.5 kilograms together having a velocity. Okay. So accordingly, give me the answers quickly now. We can find out the answers now.
The screen is blur.
Sorry?
The screen is blur.
Screen is blue. Okay. Yes. Right.
Okay.
It's 43.2 into 4.10. This gives, I think, just take it if it is correct, 177.12 plus 0 is equal to 43.2 plus 2.5, 45.7, I guess. 45.7 into V2. So what are you supposed to do? You have to take this 45.7 here. So 177.12 should be divided by 45.7 is equal to V. Okay. 43, 45, 45.2, 45.7. Yes.
So I
So
got 3.87571116.
3.8757. Yes, exactly. So we'll take the answer 3.875. 57, I can take it as 3.876, right? Isn't it? 875, I can take it as 8.7 because 57 goes on. So in fact, I can take it as 3.9 also, isn't it? But it depends on the question, right? So let's say the question is saying that take it subjected to the first decimal, then you have to give the answer as 3.9. Two significant figures they see, then two complete figures should be there, then 3.9. Let's say the question says three significant figures, then you have to enter the answer as 3.8. When you subject this, it becomes 8. Why? 76, right? 76 no 76 means you can take it as 80. So 3.88, three significant figures. Four significant figures, 3.876, because the next one is 57. So some words will be added in the question to give you marks. So make sure you don't lose them. Okay. So accordingly, here, what is the combined velocity? 3.876. Since nothing is mentioned, let me write like that. Is meters per second. 3.876 meters per second. So if you ask me again, if can't we write 3.9, you can write.
So I have a question. Can't we just write in brackets those 2SF and 3SF or decimal places in brackets?
Brackets.
After writing the meters per second per unit, we can just write in brackets, right? The brackets 2S.
So did you mean after writing this like this?
No, so like after writing the meters per second, like how much we rounded it up, we should write it to SF.
No need here. It's not needed here. It's not needed here. You have to just write it as that means did you mean that significant figure? Yeah, significant figure. SF, yeah, significant figure when you come, they mention in the question, right? So as they mention to get it as a significant figure, then you don't want to mention again SF. Straight away you can write the answer. In fact, they will be giving a line for you to write only the value. You don't want to mention that. Okay? Is that clear?
Yes, sir.
Got the point, right? So 3.876 meters per second, that is our answer here. Combined velocity. Fine. There's another part of that question. It goes as a yeah, verbal part, right? I mean, wording questions are there. So I hope this part is clear to you. Correct? Totally clear? You got any questions over there here? Sharin, could you correct it? Could you correct this? I hope your answer was slightly wrong, no?
Yes, I heard.
Yeah. Okay. Fine. So momentum we learned today. Momentum conservation we learned, and some questions also we need to make it assured that we understood. Plus mass and weight. So that is a part. Actually, in the first unit, the last part was that, and somewhat for physics only there is a part. Do you learn that physics only part at school now? Have you done all these things at school now? Not yet. Or done? Sharon, this is
Sir, can you repeat what you told? I couldn't
yeah.
hear.
Did you do all these lessons at school?
No, sir, we are still in first lesson.
Moment.
Still.
How about Sharon?
What, sir?
Sharon?
No, sir.
Okay. So fine. Anyhow, so next we do have a small part that comes specifically for physics only paper, but yet I will be taking a small part in the next class about that. That is on about the moment, not the moment. This is about momentum. Another physical quantity is they are called the moment. So about the moment we'll be speaking on the next class, and along with we'll try to do some more questions before starting up with the next, because unit is done. Totally the first unit is done. Okay, and a small part moment is especially there. Fine. I hope the lesson is totally clear. So please keep on revising. And once some questions are ready, you will be getting into a paper like. Okay. Fine. So shall we end up then? No questions, right? Okay. So see you then in the next class. Good night. Bye.
Yes, sir.